So yeah, welcome everyone. Today I'm going to do a presentation about Delta Lake and how you can use Delta Lake to build next generation big data applications. By the way, before I start, does anyone already know about Delta Lake? Like, if you raise your hand. Okay, got a couple of people, cool. So yeah, let's just start by looking at the agenda. So first part will be regular introduction. What is Delta Lake? Why you want to use Delta Lake? Then the second part will be more about like a deep dive. I'm going to talk about all the features of Delta Lake. And then finally, the final part will be a demo, and then the regular conclusion, and a small Q&A session. So yeah, just first start with the introduction. So my name is Theo Lebrun. I'm a data engineer and technical manager at Epon Technologies. I currently live in New York, so you can see I really like pizza and New York style pizza. So I don't know if it's a big thing in Atlanta, but yeah, in New York, we're pretty big on the pizza scene. If you want to connect to me, with my social, my LinkedIn, or my GitHub, Twitter, and also my personal website. And also for the little story, so I used to be a software engineer, doing like a lot of Java, Spring Boot applications. And then I think 2-3 years ago, I switched to data. So yeah, let's just start by talking about the past. So if you're into the data world, you probably already know about like Hadoop. So kind of like an old technology, was created like 17 years ago. I don't know if anyone in the room used Hadoop before, but back in the day, it was very powerful. It was three main components. So HDFS for like the file system and everything. Then you have a MapReduce, Yarn. So it was pretty nice, pretty big, pretty useful. But there were like few issues with Hadoop. So for example, you cannot really look at the data directly. You have to use binaries like the Hadoop CLI or HDFS. And same thing if you want to create folders, if you want to navigate through those folders, it's not that easy. So once again, it was amazing back in the days. Now I will say it's a bit old. It's been running around for like 17 years, so you can tell like we kind of need something new. So yeah. So now a new concept was introduced. I don't know how many years ago, but like more recently, like a data lake. Well, what's a data lake? So essentially, a data lake is pretty simple. It's just you can have all sort of data, structure, unstructured, semi-structured data. So JSON, CSV, PDF, Excel spreadsheets, whatever you want. And the whole point is that, well, because storage is very cheap, the whole idea was like, let's just put all our data in our data lake. Let's just store everything, and then we can like query it and everything. So like I say, it could be like on the cloud, like on AWS S3, for example, or like just on-prem on your storage system. And there are like few issues with that. But the first one is that if you don't really take care of the quality of your data lake, it can quickly become a data swamp. You need to kind of be careful of what kind of data you have, because if you start storing everything, then at some point it's going to be like very messy, and you can have trouble querying the data and all those things. And also like the diagram on the right kind of like explain that in order to read your data, well, first, like for an example, like if it's on the cloud, first you need to get the list of files from your cloud service. And that can take a bit. It's like an extra step. And then once you have that list of files, you will be able to read your data. For example, if it's Parquet file. So that's kind of like what Spark is. If you're like familiar with Spark, that's what it's doing under the hood. It's like, hey, tell me like the list of Parquet files on S3, for example, and then I will be able to read the files. So I kind of mentioned, about Parquet files. I'm not going to go into the details about Parquet files, but if you're not familiar with Parquet files, it's basically a type of like a file type to store data. And if you want to be like organized, you can have your data lake with Parquet files, and that's kind of like what's mentioning here. It's called a Parquet lake. But Parquet lake, there's few issues. So the big thing is the Parquet files, they're like immutable. So if you want to change the Parquet file, you have to rewrite the Parquet file. So if you have like a big data set with like very big Parquet files, every time you make changes, you're going to rewrite your data. Obviously, it's not ideal. It's going to require like a lot of processing power. And depending on if you're on the cloud or different or like on-prem, it's going to cost you money at the end. So not ideal. And you also have like no ACID transactions. So what it means is if you have let's say a process that create data, so create a Parquet file, and then that process fails, well, you're gonna have a corrupted Parquet file. So if you try to read it, if it's corrupted, it's not gonna work. It might work, but you're not gonna have all the data, right? Because the process that failed didn't finish writing the Parquet file correctly. And then there's like the last thing is if you want to do schema evolution, if you want to update the schema, so if you want to add new columns, if you want to remove columns, if you want to, I don't know, declare some additional information, you're going to have to rewrite the whole Parquet file. So imagine if you have like a very big table, like terabytes of data. Every time you're making changes on the schema, you're going to have to rewrite all those Parquet files. So obviously not ideal. So that's kind of all about data lake and also Parquet lake if you're using only Parquet files. So now you understand kind of like all the issues you have with a regular data lake. So how can you solve that? Well, it's pretty easy. That's why Delta Lake was introduced. So it kind of like fixed a lot of things of like a regular data lake. And just to give you like a little story about Delta Lake, so it's open source, fully open source. You can check out the source code on GitHub and everything. Under the hood, it's actually backed up by Databricks. So the main contributors of Delta Lake, they're all Databricks people. So I will say it's a real company behind it, right? It's still open source and everything, but it's cool that behind it's also a real company. It's not just people from all across the world that are like contributing to the open source project. And you can see that it integrates with a lot of technologies. So obviously, Spark. But you also have like other technologies, like Kafka, Snowflake, Amazon Athena, for example, and of course Java, since with Spark. So yeah, very like a lot of integrations and everything. And yeah, like Delta Lake fixed a lot of things, like had like new features to your data lake. So the first feature is the transaction log with metadata. And what it means is basically every time you add data, every time you change the schema, like all those operations, it's actually going to write an entry into the transaction log. So I will like show you more into details during the demo. But the idea is that every time you do operation on your table, you're going to be able to see all those operations. Another thing, it's called file skipping. And what it does is basically based on your table, it will know some extra information. So for example, if I have a column with null values, it will calculate in advance how many null values I have. So that way, if I'm asking like, hey, can you give me like how many null values you have for this column? It knows right away. It doesn't have to read all the table and then calculate that amount. It already knows that. There's also like the min and the max. If you have a column with numbers. So that way, if you ask for the minimum value, it doesn't have to read the files. They already know that based on the metadata. Then you have like another like feature I will say is your data is partitioned. So if you're familiar with Hadoop, you know that you're supposed to like partition your data. So usually you partition, let's say, by year, by month, or even by day if you have like a lot of data. And obviously, since partitioning the data is not really a new concept, the Delta Lake does that as well. Something that is a bit new that Delta Lake does also is called Z-order. And it's a bit complicated to explain, but the whole point is that if you partition your data on a column that is low cardinality, so that doesn't have like a lot of values, it's perfect, right? Because you're gonna have like not a lot of files. But if you do it on a column that has like a lot of values, well, it's not gonna be good because you're gonna have a lot of small files. So then when you're gonna read all your data, you're gonna have to read all those small files one by one, and that's obviously not ideal. So instead, you're gonna use the order. And basically, the order going to collocate the data together in files. So that way, when you read the data, if it's on a high cardinality column, it's going to work like super fast. Again, it's a bit complicated. If you want more details, you can just check online. There's obviously like a page that will explain way better than me. And then the other thing is the interoperability. Kind of like a strong word, but basically it just means that you can interact with Delta Lake, with Java, with Scala, with Python, even with Rust if you want. So it's very, very easy to switch languages. You don't have to stick to one language or one technology. You can use any type of languages, the one I said. And then the last one is the deletion vectors. And the whole point is that when you basically when you remove data, if you think about it, when you remove data, you need to rewrite your Parquet files, right? Because like I say, when you change the data, you have to rewrite the files. Well, with deletion vectors, what you do instead is you write vectors, like deletion vectors on the side. So that way, when you read your data, you basically read the Parquet file as usual, and then you remove the data that is in the deletion vectors. Again, this is like just for like optimization. But it's just useful to have that feature because, like I said, if you have a very big table and you're doing like a lot of deletes, you don't want to rewrite the Parquet files all the time, right? That's going to cost you a lot of money. So yeah. So those are like kind of like all the big features of Delta Lake. I will show you more about it during the demo at the end. But let's just first start by looking at what's the Delta table and kind of look at all the features of the Delta table. So the first thing I mentioned is ACID transactions. So what it means is every time you do operation on your table, if you create new Parquet files, if you remember before I said if you have a process that write a Parquet file and then fails, then you have a corrupted file, right? A corrupted Parquet file. Well, with Delta Lake, essentially what's happening is all the operations, they do the same, right? They write Parquet files, all that stuff. And then the last operation is to add the line, you can see like all the way on the right, add the line in the transaction log. So that way, if everything goes fine, when you're going to read your data, you're going to read the transaction log and you're going to know which files contain the data, okay? So that way, you're not going to have an issue with corrupted Parquet files and all those things because the last step will be to write in the transaction log. So that way, that means the process was successful, right, when you change your table. Another thing is you have a batch and streaming. It's all unified. So you don't have to use a different format or like migrate your table or whatever. If you want to do batch or if you want to do streaming, Delta Lake is going to support that by default. So you don't have to do anything else. So that's pretty cool. There's no need, like I said, no need to migrate your data or like your table. And then we have obviously the regular DML operations. So if you want to create, update and delete data, you can do everything. And you can even use, I remember I talked about the languages, so Java, Scala, Python. You can also use SQL if you want. You can directly write SQL queries. If you're using Spark, for example, I will show you in the demo, but you can just write your SQL queries with Spark. And then just one last thing to mention is the metadata is scalable. So that way, if you do like a lot of operation, very common when you're streaming data, if you're doing, if you're changing your table every second, that's going to create a lot of changes. And by having the transaction log with your data table, then you'll be able to like scale. And if you want to go like more into details, what Delta Lake does under the hood is after like I forgot exactly the amount of operations, but after a number of operations, it basically takes all the operation from the transaction log and create like a checkpoint. So that way, next time it reads the transaction log, it's way faster because it already has access to the checkpoint. So yeah. So now let me start by talking a little bit about schema evolution and why with Delta Lake it's very, very efficient. So think about it. Like I say, Parquet files, they're immutable. You need to rewrite them. Cost a lot of money, a lot of time, not ideal. So with Delta Lake, for example, if you change the name of a column, well, you don't have to recreate the Parquet files because Delta Lake, under the hood, it basically does the link between the name of the column in the Parquet file and the name in the column in the table. So that way, when you do a rename, it just rename the column in the table itself. It doesn't have to rewrite the Parquet files to rename the column. So that's pretty cool and pretty easy. Pretty like same logic for if you drop a column. So if you drop a column, well, Delta Lake is just going to be like, okay, that column is dropped. Doesn't have to rewrite the Parquet file without the column. So it would be like useful if you want to save space. Let's say you have a very big table and you're dropping, 20 columns. Well, maybe you want to rewrite the table, right? Because if you remove those 20 columns from the Parquet files, you're going to get more space. So you're going to save space and I guess save money. But if it's like a regular table, don't even bother. Like you don't have to do anything, and Delta Lake will simply like add a new new line, in the transaction log, and that way we'll know that the column was dropped. And then you can also do, if you want, schema enforcement. So if you want, like for example, when you have a table, you had a new column, Delta Lake can be like, hey, you're not going to be able to do that because the schema from your source is different than the schema from your destination. So no schema evolution. It's basically to control, like if you don't want to evolve the schema. And then the last thing is check constraints. So if you're familiar with like SQL engines, you can do constraints. So let's say, oh, on my column A, if the value is more than 20, then it's not going to insert anything. So you can also do that with Delta Lake. So it's cool that you have all those features, especially if you're used to a SQL Word. That way you can keep having your constraint and all that. Now I'm just going to talk a bit about two other features for Delta Lake. So time travel. What it means is you're going to have access to all the versions on your table. So every time you had data, you rename columns, all those things, they're all going to be stored in your in the transaction log. And then you're going to be able to time travel. So if you want to go back to the previous version, you can like just you can even do a select on the previous version, for example, just to see how the data was looking back in the time. You can also do a rollback if you want. Or just reproduce if you want to reproduce like something that happened in the past. So that's pretty cool. And then another feature is the audit history. So like I said, you can with the transaction log, you can just see all the operation on your Delta Lake table and see what happened. So that way you can have an idea like, oh, okay, so we renamed the column, we dropped the column, we added some data. You're going to have access to all of that. And then two other operations that you can do on the Delta Lake table, so optimize and vacuum. So I kind of mentioned, I talked about like having a lot of small files, not ideal when you're reading data. So then what you can do, you can run optimize, and what it's going to do is going to like compact the data through all your Parquet files, together, and have files that are like around like 500 MBs. That's kind of like the ideal size for a file. So that way, if it's very useful if you're doing streaming, you're always writing data, so you're always writing Parquet files. And then at some point, you're like, okay, let me run optimize. So that way, it's going to take all the small files and compact them into a bigger file. So that way, your read's going to be way more optimized. So yeah. So like I said, it's called compaction or like bin packing. And yeah, it's already included. You don't have to do it yourself. So very easy. And then you have vacuum. So I mentioned, time travel. You can go back in the past, check the status of the table. But what you can do is, at some point, you want to be like, hey, maybe we don't care about the version like a year ago, because at the end you have the Parquet files and everything because you can go back to that version. So what you can do, you can just run vacuum, and it will basically remove all the previous Parquet files from the previous version. So by default, it's 7 days. But if you want, you can obviously change that value. Again, this is very to like save money on your storage, price. I know storage is pretty cheap, but sometimes if you want to save money, you can just run optimized and remove files that are older than 7 days. The big problem though, and you will see during the demo, is if you try then to go back to a previous version, like especially if the version was more than 7 days, well, it's not going to work, right? Because the Parquet files, they're not here anymore. So now let's do a quick demo, just to showcase kind of like all the features of Delta Lake. So I'm going to do like a couple of things in the demo. So I'm going to just show you like how to ingest data, create a Delta table. Then we're going to like update the schema, perform a merge. If you're not familiar with a merge, it's basically an upsert. So you're doing either an insert or an update, depending on a condition, like on your key. And then just run optimize and vacuum just to show you how it works. And then also I want to showcase how you can read data with polars. If you're not familiar with polars, it's like pandas. I'm pretty sure like, if you don't know pandas, it's basically a Python library, to create data frames and all that stuff. I personally prefer polars because it has like, I would say, better features. I can talk more about that, but instead of using pandas, I'm just going to use polars to read the data from my Delta Lake table. So yeah, let's just switch to the demo. So I have like a regular, Jupyter Lab notebook. So I'm just going to start it. And yeah, let me increase the font so everyone can see it. I think it's big enough. Yeah, so the first thing, I'm not going to run it, but obviously I install like some dependencies, so PySpark, Delta Lake, Polars, and DuckDB. And then the first thing I'm going to do is just set up my Spark, just my Spark builder. So here to interact with Delta Lake, okay, to interact with my table, I'm going to create a table. I'm going to do like some operation on it. We're going to use Spark, okay. I don't know if you ever try to use Spark locally, it could be kind of like annoying to set up. Like you need to install Java, Scala, like use Maven, like you need to do some operation, especially with PySpark. But now it's actually pretty easy. You can see now I already have this function like configure with Spark with Delta pip, and it basically does all the job for me. So it was actually, I was surprised how easy it is to set up now. I remember like maybe like 4 years ago or something, I was trying to play around with PySpark, and it took me like like a few minutes to get started. Now it's like way easier. So here I have my builder. I have like some configuration. I'm not going to go into details, but there's like couple things that I'm configuring. And then like I say, I'm configuring, like I'm creating my Spark instance with my builder, and then I'm just whatever setting the log level to error so it doesn't like show like a lot of stuff. So I just run that cell. So here again, it's just going to create like a Spark instance locally, with my different options, and then I'm going to be able to interact with Delta Lake. So here, I have my my logs, and now we can actually load data and create the table. So the first thing I want to show you is actually what kind of data we're going to play with. So here I have a CSV. This is just like stock data about Apple. Basically, it's open, high, low, and close for like a date, and also the volume. So just like stock market data. At the end, there's basically a row for each day. So you can see on the left, I have like November 17, 16, 15, etc. So that's my CSV. Again, pretty simple. The CSV itself, there's, I don't know, like 6 columns, some data, nothing too crazy. So the first thing I'm going to do, I'm going to read my CSV. So here, very simple. I'm just reading my CSV, and so now I have my data frame with all my data. Then I'm going to do some, I will say, classic data engineer work. I'm going to convert the date to a real timestamp. I'm going to convert the volume to integer. Same thing for like close, open, high, and low. So again, I'm just going to use the same data frame. So now you can see it's the same data, is just the data is cleaner, right? I have my timestamps, I have my numbers in the right format and everything. So now I'm like ready to create my table. So here's the instruction to create my table, and let's just go through it, just to have more details. But yeah, the first, I'm just saying, oh, my table is just going to be called my table, and then I have the path where it's going to be stored on my local computer, and then so I'm specifying, hey, here's my table name, here's my path. Here, pretty cool. So I'm basically saying take all the columns from my data frame, so I don't have to manually write all the columns one by one. I can just be like, oh, here's my data frame. You're going to use the same schema. And here I'm doing like two new columns that it's called like a generated columns. And what it means is basically it generates the column based on like an expression. So here, for example, I have my column year and my column month. And you can see I generate using the year function and the month function based on my date. So long story short, what it's doing, it's extracting the year and the month from the date column. So that way I don't have to manually be like, oh, that column, for example, for 2023, 11, 17, I don't have to manually be like, oh, you're going to be like, 2023, and then the month's going to be 11. No, here I can directly use a generated column. And, essentially it's very simple. I just run the SQL function year on my date column, so that way I can extract the value. And same thing for month. And then I'm partitioning my data on year and month. So like I mentioned before, you want to partition your data so that way you don't have like a lot of small files. And here we're doing it with year and month. So that's my column definition. It's just to create it, by the way. Then I'm writing my data to it. So you can see here I have my data frame, and I'm saying, hey, you're going to write my data frame to my table, and you're going to like append the data. again, the table was just created, so it's normal to like just have the data like that. And then finally, I'm just going to display my table. So let's run that cell, and we'll see at the end. It's taking a few seconds because under the hood it's using Spark. Spark is very efficient, but it's still like some like startup and everything. So for like a very small operation like that, it actually takes a couple seconds. And now we have our table, and this is like, if we look at it, this is really the data frame from the table. You can see here I'm like reading my data frame using the table name, and here you can see that I have my year and month column, and it was like correctly extracted from my date column. Okay, so all my generated column worked pretty well. And then if I go in my just in my folder, you can see I have my table here, and if I look at it, remember it's partitioned on year and month, so I have my partitions here. So if I go to 2023 and then January, then here I have a Parquet file. I mean, the name of the file is quite long, so I don't think you can see it, but it's a Parquet file. Like maybe if I go like that, the name of the Parquet file is generated, right? So it's always like an ID, but you can see it's a Parquet file. So that's my my Parquet file that has the data for January 2023. And if I want, I can also I can look at the transaction log in my Delta log folder. So if I go in my Delta log, I have like 2 JSONs. And if I open that JSON, you can see the first one actually contains the table definition. So it say, hey, here's my table. You can see here I have my columns and all that stuff. And then if I open the second one, it will contain the information about the Parquet file. So again, there's like a lot of content. You're not supposed to really look at the JSON because it's very complicated. But if you want, you can, right? If you want to know exactly what's happening. And then if you remember, I was saying that you can see here I have a property called min values, and it tells me, hey, for date, the minimum value is 2013, blah, blah. Same thing for like close last. So it's that's like by having those data, you're able to like I say, skip files, right? Because Delta Lake already know what's the minimum value for that column. You also have, you can see here, you have like max value, and also like I was mentioning, null count. You can see there's no nulls, right? But if we had nulls, it would be able to skip the files because they already had the information in the transaction log. So that's really for the table itself. Again, you're not really supposed to look at those JSONs, but if you want, you can, right? It's a very like a lot of details. So I'm going to go back to my January 1st, 2023. And then let's see what else we're doing. So first thing I want to show you is how to update the schema and merge the schema. So here, what we're going to do, we're going to add a new column. Okay, we're going to add a new column called ticker. Ticker is going to have a value of just Apple, because again, we're looking at like Apple stocks. So we're just going to give the correct value for all the data. And here, what we're doing is we're saying, hey, I want to do that only for January 2023. So here we added a new column, right? We're adding the column ticker. So we're like evolving the schema. So here I define, my new column, my new data frame, and then I have my data frame number 3 here, and then I'm going to write that data frame to my table. And here, very important, I'm going to be like, hey, you're going to merge the schema, okay? Merge schema equal to true. So I'm going to like evolve the schema. And then I'm going to like overwrite the partition if they already exist. So that way it's going to overwrite the partition for January 1st. January 2023. And then at the end, as usual, I'm just going to display the table just to show you that everything was correctly created. So here, if I show you the table, you can see now we have a new column, right? Ticker. But you can see that the value is always null. Well, that's normal because the date is like 2014. It's not 2023 and January. So if I go to the other cell, now I'm using the same filter, and you can see I have my my column ticker, and I correctly have Apple in my column. So here, very easy. We added a new column. We specified a value just for like a subset of the data. And you can see that it correctly added the column, put null values for like when the data doesn't match the filter, and then when it matches it actually put the value that we want, Apple. Now we're going to do another operation. So we added a new column. Now I want to do a merge, or like I said, it's like an upsert. And here what we're going to do, we're basically going to update the volume. So I want all the volume to be 0, okay? So here what I'm going to do, I'm going to do the same operation, and I'm going to say, hey, for every time the date, is matching my date from my new data frame, so my data frame number 3, which is, by the way, the data frame number 3 is the one with the filter on January 2023. I'm going to set the volume to 0. And then at the end, as always, I'm just going to display the table. So here, if we show the table again, you will see that I have my volume is equal to 0 now. So I updated my column, right? But only for January 2023. Like if I look at the data from another date, it would be the correct volume, not 0. So again, very, very easy to perform a merge and everything. And now I just want to show you, like if we go back to my local file system, you can see that now I have 3 Parquet files. So if you think about it, it makes sense because the first Parquet file is when we initially wrote the data. The second Parquet file is when we added the new column taker. And then the third Parquet file is when we set the volume to 0. But this is only for January 2023, right? If we look at another month, there's only 1 Parquet file because if you think about it, the data was not changed. So let's go back here. So now, I've done like few operations, a bit complicated. So now I can just run the history command, and it's going to tell me like all my history on my table. So you can see I have like multiple rows with like a multiple operation. I'm just going to do the same command, but only to select like a specific set of columns. So that way it's more clear. So you can see in total I have like 4 versions. So they have like the timestamp when it was done, and also like what kind of operation. So the first one was create a table, then we wrote the data, then we create or replace with a select, which is basically when we added a new column, and then we did a merge. So pretty cool that you can check all the operations, and of course like you have access to metrics. Like for example here on operation metrics, I mean you can't see the whole thing, but you can see that it tells you like the number of files that were affected. So the first time we created a table, it actually wrote like 121 files. So pretty cool. It gives you like all the data, like in case you want to do like some auditing and kind of know what happened. So then now the thing I want to do is I want to read the data, but like back at a previous version, right? Just do like regular time travel. So here I'm going to say, hey, can you give me the version when it was 1? So if I run that command, you can see that I'm getting the table like it was when it got created. So there's no ticker column, and the volume is the right volume. So very easy to switch versions. And now what I want to do is like vacuuming. So if you remember, vacuum it's when we remove data. So if you want to save space, and here I'm saying 0, so basically 0 days, so 0 hours actually. Sorry. So it's going to remove everything except from the latest version. So if we run the vacuum, it's going to take a few seconds, but basically it's going to remove the files that are like from the previous version. And now if after the vacuum is over, so it's going to give me like a small summary, by the way, tell me, hey, at the end I removed 2 files, blah, blah. And then if I rerun this command, well, what's going to happen? Well, it's not going to work, right? Because I'm trying to go back to my version 1. But that version just got vacuumed, right? It doesn't exist anymore. So I'm going to have an error, right? It's going to tell me, basically, if you look at the error, it's going to tell you that it tried to look for the file, and the file is not there anymore. It's unfortunate, but again, this is for the demo, so it was all on purpose. And if I go, if I show the history again, the audit history, you can see I have my vacuum start and vacuum end. So I know that someone ran vacuum and removed the previous versions. So let's keep going with the demo. Well, it's like a big error message. All right. Now I want to take I already kind of talked about like file skipping, but I want to talk about it again. What it does is, you can see here, so again, remember I'm using the same filter, so January 2023. And here, if we take a look, so this is like the the explain plane of your SQL query essentially. And if we take a look at the detail, you're gonna have like a partition filter command, and the partition filter is going to tell you, hey, you want the data for the partition January and 2023. So I can see here I have my condition here, right? It says, hey, year equal 2023 and month equal 1. And basically what it is doing is going to know that it only has to read that partition. It doesn't have to read all the data and then filter out the data that doesn't match the filter. So again, very, very basic file skipping. So that way you only read the files that you're interested into, and you're not going to like waste time, reading everything and then filtering out. But you can see that what I want to showcase is, because if you remember here, it's using the year column and the month column, and those columns were generated, right? But if you take a look at this query, same thing, I'm going to run the plan. So if we take a look at this query, this time I'm using date. So I'm saying, hey, I want the date between January 1st, 2023 and January 31st, 2023. And here, Delta Lake is smart enough to generate the partition filter based on that query and knows that, oh, I have my year and month column generated from date. So then I can do the same thing. I can also do file skipping and just read that specific partition. So you can see that the partition filter is a bit bigger, but essentially it's doing the same thing. And at the end, it's just saying, hey, don't read all the data. Just read the partition that match that condition. So pretty cool. And again, it's just to showcase that it will run faster and skip files. So that way you don't have to read the whole data, the whole table. So now that I showcase how you can create a table, update it, do some operation, read the data, all that stuff. That was all done with Spark, by the way. So Spark has some disadvantages because you need to have a Spark cluster and all that stuff. So now I just want to showcase that you can also read data without Spark. So that way you don't have to rely on a Spark cluster. You don't have to deploy your stuff and compile it and all that stuff. So here, for example, I'm using polars, which is basically like pandas. And I'm like, hey, you can see I already have this function read delta. And I can be like, hey, here's the path of my table. And then here's some like options. And essentially here my option is just to be like, hey, give me the year 2023 and the month 1, right? And again, this is just to showcase that you can also do a file skipping with polars. And in that case, you're just going to read like a specific partition. And then if I run that, I'm going to get my data frame back. So everything looks good, right? I have my ticker column with my new column, and also my volume is equal to 0, right? Because this is the latest version of the table. And here, I'm not using Spark, so that's why I was super fast. I'm like reading a Parquet file, so it's pretty efficient, and you don't have to depend on Spark, which like I say has some advantages in some situation. But the cool thing with polars, you can also read a specific version. So for example, if I say version 2, remember I did a vacuum, so polars is also failing, and it's telling me, like, if we take a look at the error, it's telling me, hey, the Parquet file was not found. But if instead of using version 2, if I use version 3, everything works fine. So it's still cool that with polars you can specify the version. So that way, if you want to read a specific version of your table, you're going to be able to do that. And then another example I want to showcase, if you don't want to use polars, or pandas, you can also use DuckDB. I know DuckDB is kind of like a new SQL engine that is performing very well. So here, just to showcase how you can use DuckDB, to read your data. Here, very very basic. We basically getting our delta table from the path. We're converting that into a PyArrow data set. And then we're able to read it with DuckDB using the arrow function. And then same thing, I'm using the same condition, hey, just filter the data based on the dates. And then here, if I run, same thing, it was super fast. And now I have my data frame with DuckDB. So again, this is just to showcase that you can use polars, pandas, or even DuckDB to read data if you don't want to rely on Spark. So yeah, pretty cool. So that's pretty much it for the demo. So let me just go back to the slides. So again, we showcase like how you can ingest data, create delta table and everything. Then you can update the schema, perform a merge, and then run commands like optimize and vacuum and everything. So now, just to before I finish, just want to talk a bit about the Delta Lake ecosystem. So the first thing I talk about polars, if you want to read data, there's a link that explain to you how like all the things you can do. Actually, let's take a look. That'll be like easier. Let me do some zoom. So you can see here you have like read data, scan delta, and you can also actually with polars now you can even write to a delta table if you want. And by the way, the difference between read delta and scan delta is just like if you want to do like a lazy data frame. Because I don't know if you ever had that with pandas, but with pandas, if you try to read like a super big CSV, for example, it might just run out of the memory and all that stuff. So what you do with polars instead, you basically scan your file, and then you can have some filtering. So that way, because it's lazy loaded, Polar is not going to load the whole thing and then filter. It's going to do it on the fly. So that way, if you don't have a lot of memory, you're going to be able to do that with Polars. So that's the thing about Polars. Then we have also, if you really don't want to use Spark, you can also use the Rust implementation. If you're not familiar with Rust, it's like another language that is kind of like a low level. And basically, you're going to be able to do all the operation that I showcased in the demo. So create a table, read the table, update the table, and everything. But you're not going to use Spark. So that way, again, if you're like in a limited environment, you can use those libraries. Another thing that is cool is called delta sharing. And delta sharing, it's if you want to share data, data across systems. So basically, data sharing is a protocol. So that way, you're going to have a delta sharing server. And if, I don't know, you have someone that is interested into your table, you're going to be able to share the table with the other person pretty easily. And you can see that, the recipient, it can be like very big solutions, like Tableau or like Power BI and all that stuff. So that's pretty cool feature that just, easily you can share data across systems. Then if you really want to go into details, you can take a look at the Delta Lake protocol. It's a big document, so I don't really recommend doing that. But if you're really interested, it tells you the whole protocol and how it works and everything. I think it's kind of interesting to know all the different features and how actually the contributors thought about it. So again, if you're interested and you want to dig into that, you can totally do it. And then of course, the the Delta Lake website, it has all the information that you want. So if you're interested, just check out the website. They actually redid the new diagram. So it tells you exactly how things work and how you can integrate with other systems. So pretty cool. And then finally, this is if you want to have access, to the notebook. It's on my GitHub, so just on my talks repo. So that way, you can have access to my slides and also the Jupyter notebook that I use for the demo. So if you want to do the same thing on your laptop, that way you can run the same operations and everything. All right. And yeah, so that's it for today. So yeah, I just want to say thank you for your time and everything. And yeah, if you want to chat more, I would love to talk to you. If you have any questions, if you want to build a data platform using Delta Lake or any other kind of data technologies, you can definitely reach me out. I mean, you have my email here, but you can just come after the talk and just talk to me. Yeah, it's on GitHub. Sorry, let me show you again. If you go on my personal GitHub, okay, you have you have I have a repo called Talks. And then you're going to have the slides. You're going to have also the CSV and also the notebook with all the information that I run for the demo. Cool. Thank you. Yeah, Spark, yeah, it's running locally, yeah.
So what is the one we need to run it in the local?
What is the what?
So what to run in the local?
How did I do it? Yeah. Okay, let me show you. So what I did is, if you take a look at the notebook, the first cell, that's a long, yeah, right here, that's how I'm setting up my my Spark stuff. So
we don't need to always in the Azure.
Exactly, yeah, you don't have to be on the cloud, you can just do it locally. The thing though, you're going to rely on your computer. So if you're doing a lot of operations that are super heavy, it might take time, right? Because it's going to run on your own laptop.
So do we need any additional installation?
So no, so that's the thing now, with the configure with Spark with Delta Pip, it actually does a lot of job for you. Because before, I used to do it with PySpark, and you have to install Java, Scala, some dependency, all that stuff. And now you can just run that, and it's going to work right away. So that's pretty cool.
So this notebook URL, how we got this?
So I did.
This URL. The
Oh,
local host. No, the
which
local
one?
host 888, 48.
Oh, that's my Jupyter notebook. So, you know, I started it with this command, like right here. I did like Jupyter Lab. So you can use Jupyter Lab locally, okay? So you can create like an environment. So then you can create a notebook. So, yeah, Jupyter Lab. Jupyter with like a Y. Let me show you. So it's a Python package. So you can just, same thing, you can just install it locally and then run everything. So you see, like, you can read the instruction here. See Jupyter? It's like a Python package. So you install it, then you can start it on your terminal, okay? And then you can create a notebook. And then you can, it's cool because with the cells, like if you're not familiar, like you can create those cells, you know, and then you can just write code. And you can see here.
After installation, I need to run that command.
Yeah. Yeah, exactly. So you install it, then you start it with like, you see this command, hold on, it's kind of small, Jupyter Lab. And then it's going to start a server, and then my server, you can see it's like running on localhost, blah blah. And then I can just open the tab. May opens it for you, you know, but then you're going to be able to create a notebook. So it does a cluster, but it's very small. So you see here, like this is how I start my Spark, right? So it creates like a Spark cluster, but it's tiny. So that's why for the demo it's perfect, but if you have a lot of data, it's not going to work.
If you are trying to look in the local, so I install a Jupyter,
Yeah.
then I run the command.
Yeah.
Then I got this PySpark. I mean to say this
So-
localhost.
Yeah.
Then if I want to connect to the database.
Yeah.
So I have a JDBC
Yeah. But you're going to have to do it in Python.
or Python. Yeah.
Yeah.
I will connect it to the database, and if I want to retrieve it, still I can do with the local.
Yeah, I mean, as long as your laptop has access to the database, you're going to be able, so you can use it any driver that you want. It's going to have to be Python because, so you see here, so this is like on the left, you see this is my file explorer. So I can just do a right click and do a new notebook. So again, it's going to be empty, but I choose like a kernel, you know, Python 3, whatever. And then I can write my Python code. And by the way, like if I go to my terminal.
Does it also help create a catalog? I mean,
So I'm gonna show that after. So here I'm in my folder that my talk, right? And you see if I do like ls.la, I have like my CSV, I have my Python notebook, I also have my table and everything. So the Jupyter Lab is linked with your laptop, okay? And then yeah, like once you have your notebook, you can just put whatever you want, and it will connect. Like you can connect to a database, retrieve data, and all that stuff. But at the end, it's going to run on your laptop, so you got to be careful, right? If you load a lot of data.
In my local, I can just try to write some data. With
Yep.
the filters, everything,
Yep.
connect the database, write the file into one
Exactly.
file,
Yeah.
small
Yeah.
file, to make sure everything is working, my commands are working.
Yeah, exactly. Exactly to like, you know, not troubleshoot, but just to test and do that. It's perfect. So yeah, the catalog. So it's right there. So you see here, I'm specifying. So are you familiar with Spark? Okay, cool. So you see here, I have my configuration, and you can see here I have my Spark catalog, and I'm basically using a Delta catalog. Again, it's like a local thing. So it might not, it's for production, you don't want to do that, right? But for like the demo, that's cool. And you can see here, I have like other like commands, but it's just for like, you can see here, this is the vacuum. If you remember, by default, it's 7 days. But if you want to go less than 7 days, it's going to block you. So here, this option, I'm like saying, sorry, this one, I'm like disabling the check. So that's why I was able to do a vacuum with 0 days. And then the vacuum is just to be faster, so it does things in parallel. So yeah, you can specify like your Spark options and then run it. But yeah, at the end, the catalog is this one, the Delta catalog.
for example, in my local, if I want to connect it to a database, I can, start and Dockerize instance of the database.
Yep.
locally, and then I can.
You can grab data from your database and then using Spark write files. Yep, exactly. Yeah, just to like play around, you know, troubleshoot and everything. Yep.
Very good, very informative.
Well, yeah, of course. And you know, like if you have more questions, just send me an email and everything. You know, I'm like available. Yep. Sorry.
So what is the Docker container? You're saying you can run the Docker container?
Well, and then it depends if you if you want to put stuff on Docker, if you want to run stuff in Docker, containerize and everything, I mean, at the end, it's Python, like a pip package, so, you know, you can have everything in a container.
You don't need to use Apache Spark. You can use the Polars.
Yeah, to read, but only to read. I mean, like, it looks like you can write data now, but I never tried it. But if you just want to read data, yeah,
What we are reading the data from database and putting into the
yeah,
Parquet files,
yeah,
and which we are reading from the we are putting writing onto the Parquet file.
yeah.
So when the data is done, any new version comes, again we are overwriting it, deleting the existing and overwriting the new.
Okay.
But we are using the Spark data frame.
Yeah. The regular Spark data frames, yeah.
But Polars is much more better than that.
So yeah, but so Polars, it's are you familiar with pandas? Okay. Okay, so Polars is like pandas, it's just more optimized. But you know, you can only, I mean, you can also use Polars to write CSV or Parquet files, right? But in my demo, it's just to read data. And what I really like with Polars is, like I mentioned, the scan. You know, you can do like a lazy data frame. So if you have a big CSV or Parquet file, whatever, with pandas, it might crash because if it's so big, pandas basically under the hood, pandas load the file and then do some calculation on the columns, all those things. So if you have like a I don't know 10 gigs file, it's gonna explode. Exactly. With Polars, what it does, and by the way, the Polars, they were like the pandas people. They realized, okay, we got to redo the whole thing, so let's create Polars. And basically now what it does, it load the whole file, but then is able to filter out the data based on your conditions. So that way, that way it reads the file on the fly. It doesn't have to load it and then do some operations and then explode. So it's way more efficient. So I recommend using Polars, but you can also use pandas if it's like a small table.
Who does data frames like does it also, for example, if we have a very big data frame,
Yeah.
not very big, like if we have a
Yeah, but just big,
yeah, if we have a big data frame with a significant amount of records and we are searching for an object.
Yeah.
Okay, sometimes, I mean,
Right.
in my case, it is
Yeah.
going out of memory.
Yeah, exactly. Yeah, all the time. Yeah, I had that because it's so big that it just crashed.
Yeah, it just crashes for me.
And so what you can do, you can read chunks.
Oh, okay.
So you can do like chunks of the data frame. You can do like 10,000 rows, 10,000 rows, like different chunks. So at the end, that's what Polars is doing under the hood when you do a scan, right? It just do chunks instead of reading the whole thing. So